a fan of the 100% clean energy because nuclear is included and basically provides, base load generation, stability, reactive power support, absorbing reactive power, inertia, and so forth. But really, you have all the goals on one side, you got the system on the other side, and really our goal is really to bridge the gap between all this aggressive incentives, policies, and goals that most likely were non-engineered before they became a mandate in a reliable way. And then if you follow the kind of from a climate change perspective, so the last COP26, I think it was in Glasgow, the only thing that we heard back is that they want to end or stop all methane leaks by 2030. So all eyes on this October for the next COP27. We'll see what's going to happen. Next slide, please. So again, from the NERM perspective, distributed energy resources, distributed, they're all over the place. What's really interesting about New Jersey is we do not have a single renewable interconnection in the transmission side. There's like a pumped hydro that existed for a long time, but we don't have solar, we don't have wind yet, we don't have storage on the transmission. So, we always like to chat with California. We each have our own challenges, but really, I always say transmission sometimes is a little bit easier because the transmission is very stiff, thousands of MBA worth of rating. If you have a 500 kV that is rated for like 3000 amp, for example, line, that's like almost 1500 4 kV circuits. So kind of what's easy to plan for one or 1500. But for today's discussion, really, as you're going to see from some of the pictures I'm going to show you, it doesn't really take much to really cause a big hit on the distribution. So again, they're all over the place. They provide energy. Of course, it's kind of related to the weather. And, all sides are welcome. And usually, FERC always deals with generation, transmission. But I guess I'm not going to say for the first time, but the FERC Order 2222 has basically have everybody talking about it. And in very, very simple terms, they allow very small interconnection to participate in the market. So, we don't know yet if it's going to be only aggregators or utilities or both. Think of it as like a virtual market when almost everybody's welcome. So, you start putting solar storage at your house and electric vehicles, demand response, and now you're competing with nuclear plants and stuff like that. So size used to matter a lot, but now the shift is going from transmission to houses, commercial, and so forth. So we'll see what's going to happen in the next couple of years, but that's going to be a major change. Next slide, please. So this is just I'm sure a lot of you guys know that, but just very quick picture. So why are we worried? Because solar is everywhere. So you're in PSNG territory when you start seeing the solar panels on every possible wooden pole. Here's a picture, for example. Next slide, please. So it could be in a pole top solar. It could be the typical residential. I actually took this picture a long time ago in California. I was one event that many years ago. That was a time when you had to almost go to California to see solar. Now every street basically has at least one home with solar. Next slide, please. So it shifted again from residential, and then I'm a big fan of the parking deck solar because this is probably one of the I'm not going to be the only. I'm not going to say the only one, but one of the very few solar interconnections that the public don't oppose, and they actually like it. Why is that? Because it provides shade for the car. If it's snow, it kind of protects from the snow. And then if we do it right, you have enough solar. You could pair it with solar and EVs, so it's like a perfect case. So I personally expect a lot more solar parking deck. Of course, that doesn't happen everywhere. Like in New York City, it's very rare that you find parking like this. Usually they are in buildings, but the rest of the country, that is very normal. So I expect a lot of parking deck solar. And next slide, please. That picture was in Rutgers University. You got to be very creative if you're in a city. So I took this picture in Brooklyn. This is Williamsburg movie theater. If you ever go to this area, so of course there's not that much space on the roof, so they start putting a vertical solar. And a lot of countries, I think, especially Korea and other countries, are kind of ahead of the US from a perspective of putting vertical solar. However, they've been getting more popular. Next slide, please. So I like this picture for two things, right? We get a lot of interconnection. Many like companies like Amazon, right? They buy a warehouse the same day they're ready to install solar. So we've been getting a lot of commercial rooftop solar, and as the energy efficiency of the solar cells increase, you're gonna get more solar, of course, output from the same footprint. So you could see that the one on the right, that's in Jersey. It's a very busy roof. The one on the left, I think, when it becomes basically popular is going to cause a major impact, right? A lot of us cannot really install solar because you have to rebuild your roof, or it's very expensive. But this style that's like kind of a flexible solar that doesn't require that much infrastructure, doesn't require you to change the roof, that may be the future. There's a lot of small startups, small companies here and there, but I think in the future, to meet these aggressive goals, we have to get very, very flexible. You have to really try to almost meet every possible house that could generate, must generate. So something like this flexible solar may be great. Next slide, please. So this is the one that hits us the most. So this picture is in Burlington, South Jersey. As you could see from the picture, basically, if you look at the picture, there's nothing, and that's the problem. Because when you deal with large developer or community solar, their goal is to connect as much solar as possible, and that means finding the cheapest land. So a lot of time, the biggest problem is either the utilities don't have any interconnections, or we have like one limited circuit in the middle of nowhere, and that circuit already has enough solar. So that's also going to be critical for discussion today, right? The substation perspective, when you have solar farms like all the way at the end of our territory. If you guys remember back in the days when you did like voltage studies, the voltage starts high at the station, start going down, then you put a cap bank or a voltage regulator and so forth. Now it's the opposite. We have a lot of, at least in Jersey, we have a lot of locations when the voltage at the solar site is much higher than at the substation, even though the substation may be 10 plus miles, including the one you guys are looking at right now. And next slide, please. So this is kind of, I remember when California was still is, of course, a lot of solar. You always heard about the duck curve, which is the one in red, and why it's going to be a challenge because, I mean, I used to be an operator myself at the Energy Control Center. I mean, this is one of the best jobs I had. So, but I wasn't in the energy dispatch, but there was a desk. Their job was to dispatch energy as the load changes. That person would call the different power plants, increase steam or decrease steam to meet the load. Now their job gets very complex because now, first of all, twice a day, the load changes significantly, not because of the load demand, but because of the sunrise and the sunset, as you could see here. It took me a very long time to find this graph. This is from an actual site in Jersey. It's a perfectly clean duck curve. You could see in blue, no limitations. So that's, I mean, no issues at all. It's a very clean graph, very smooth transition up, transition down. But in reality, in next slide, please, that's really what we see, uh, which I'm calling the fine print. Next slide also, please. So what we really see, the one on the top left, that's what I see a lot, unfortunately. We have a lot of cloud activity in Jersey and in the East Coast in general. We have a lot of humidity. So one very important lesson, as we discussed, and I'm sure we have a lot of people from different locations here, we don't all speak the same language. Expectation of solar issues in California is different from New York, different from other locations. Like, for example, I think the best place to put solar is in Morocco in the Middle East. So that's kind of the message that I'm trying to say is like we have to be careful. So again, this, as you can see from the top left, that was actually the generation output. The bottom right, that was the feeder where the solar farm was connected. You could see how it's going up and down, up and down, up and down. And I just wanted to bring to your attention, because a lot of us are heavily involved in the substation best practice in the left. So I took this picture from a voltage regulator dial. That time, of course, when I went, it was at neutral. But, there's so much you could do. You have to go 16R, 16 lower, and in between, and you're stuck. But we don't really want to. I mean, I don't want the tap changer, the cap bank, or anything to move that much for a day like this. That picture on the bottom left, this is just the output for one day for one farm. Imagine if we have multiple farms, multiple substations, our substation equipment will not last that long. And next picture, please. Next slide, I mean. So, I personally believe that thermal is never, I'm not going to say never, it's not going to be the issue. It's always going to be voltage concerns. Next slide, please. I've been doing interconnection studies since I left from Con Ed to New York. Maybe only one system was going to exceed the thermal limit, but the voltage is an issue almost every one of them. So here in this picture, I just put the traditional tools we look for. We have the tap changer, which is a great tool. One minor issue, the transformer is very expensive. I have seen in my career before a transformer that failed because the LTC failed. Basically, there's a spark, put a hole through the transformer, and you lost cost a couple of $1 million to restore all the stuff because there was an excessive movement in a tap changer. Again, it's a three-phase system, so if you have like 5 or 10 circuits connected, all of them would be impacted. Top right, that's the single-phase voltage regulator at our 4 kV stations. I remember when I first started, I was like, why do we single-phase? I came from a place that's always three-phase. And what's really interesting is now a lot of the research believe that in the future, it's all about single-phase switching and voltage regulation because we have a lot of residential solar, and we're gonna in the future we're gonna have EVs, building electrification. So we really have to go that single phase. In the bottom right, that was actually a mobile cap bank at a large substation. Bottom middle, that's a cap bank. All of us, any place you travel to, you always see the cap banks. The easiest, cheapest way to play with the voltage. And the complete opposite case, which we'll use a lot, is the shunt reactor, like in the bottom left. Especially with the offshore wind, we expect to increase the shunt reactor significantly. So this slide, if you kind of look carefully, every single one of these is being impacted significantly by the amount of solar. And the issue is that, I worked like probably 18 years in planning. Planning is all about the peak day, peak hour, right? You work the whole year for a couple of hours, that's it. But the problem that we're discussing right now, it happens every day. Offshore peaks at night, early morning, of course. Solar peaks around noon, and that happens every single day. So what will we change? Next slide, please. So for today's discussion, and next slide, please. Like what I believe, me personally, is that's really where we're going next. So the picture on the left, that's the 1 megavar StatCom. We actually installed 2 of them all the way at the end of our territory near Atlantic City, near a large solar farm. Traditionally, if you have a tap changer, the time delay may be 90 seconds, 60 seconds or so. You have to have enough time delay between the tap changer, the voltage regulator, the cap banks, and especially you have a multiple of them. That's per circuit, per substation. Now, this device that we have, it changes status 30 times a second. So basically, you may have heard this before, distribution is the new transmission. That's exactly right. We are putting tools in the distribution system that was never meant for distribution. So this was a great success story. Of course, it wasn't like very smooth, but we're able to see. And another point that I want to bring to your attention is, in a way, stuff like that, like this slide, in a way, really helps the substation because we are taking a very important role from the substation and putting it at the field near the solar sites. And also, the developer is usually responsible for all this equipment. So it's not an impact on us for the capital or O&M. So again, it's a device that moves, and if you have a cap bank or a shunt reactor, let's say a 20 megavar shunt reactor, it's either 20 or 0. Cap bank 20 megavar, it's either 0 or 20. That's why when you have a cap bank, you have to have a filter, you have to have a series reactor, stuff like that, so to minimize the hit when it first energizes. But the StatCom only provides what is needed. So in our case was 1 megavar. I've looked at the data a lot. Sometimes it's the whole 1 megavar, sometimes 0, sometimes it's few vars. So it's really tailored exactly to the voltage demand. The picture on the right, that shows 2 main things: a couple of different inverters, large ones and small ones, and a Tesla wall. So what I'm proposing here is, like, and I've been doing this for the last couple of years, like, yes, I'll let the renewable interconnect, but you guys are the developer. They also are responsible for fixing all the issues that they discover. So if there's an issue, we're not going to be messing with our system. We're not going to be putting pressure on the tap changer to move more. We are actually going, and that's why, and if you have time at the end, we could discuss some of our interconnection requirements. Let the inverters do the job, let the Tesla wall do the job, and so forth. Next slide, please. So so another big issue that hit us, but it kind of is on snooze mode right now, was the frequency market energy storage. When I first started a couple of years ago, that was very high, the FERC had a lot of high hopes in that program. So they wanted to, I think, get ready for the future, to have the energy storage to replace the spinning reserves. So here was a picture of, I believe, a 1 megawatt battery for one day. There's the 0 line in the middle and everything on top. This is the battery discharging to the grid. Everything in the bottom of the battery is charging from the grid. That was a disaster for us for a couple of reasons. First of all, maybe FERC had good intention of helping the transmission, But the developers, they installed this battery on distribution. Imagine if you're a data center, pharmaceutical company, or anything, living across the street from this. Initially, every 2 seconds, that battery would get a different signal from PGM to charge or discharge, such that the average megawatt every hour is zero. So the total charge and discharge is zero. So that was very, very nasty, right? And to study this, we don't really have any tools to move that quick. The StatCom wasn't really used that time. And then we asked PGM, like, what guarantees that you guys are not going to send a signal to charge during the peak hour? And they mentioned that we have to assume that they're going to basically charge during the peak hour. So now on top of all the load we have, now we have to also add this as an additional load. We have a lot of loops in our system at PSNG, so that they're great. But what's interesting really is now if you have a lot of batteries like this, the battery may have worked fine, but once the loop operates, now the battery belongs in a different location. For example, just very quickly, we had a 2 megawatt battery proposed right outside the substation. But what's interesting is that there was no problem. But once the loop operates, that battery becomes the last point, all the way at the end. And if the battery was discharged, the voltage drops, we have an overload. So again, this slide just shows you that the system is constantly changing. Now, stuff like this would have an impact on our substation because the feeders every 2 seconds have a different flow from becoming a load to becoming a generator. Next slide, please. So, as always, data is very important, right? But in this case, we've been very busy putting weather data. Back in the days when utilities used to put weather data, that was mainly to look for, storms and stuff like that. But now we're looking for the solar irradiance, the wind speed, stuff like that. Now, there's a big push to increase the smartness of the whole city, but it starts from the home, the street light, the city. Then become several cities are smart in the whole country. This is something also we're working on in New Jersey, with us installing AMI and others. What can we get if you combine AMI with the distributed energy resources data, the inverter data plus electric vehicles? Like this avalanche of data. What do you do? EVs for us are becoming a major issue. So far in Jersey, the vehicle to grid program has not been developed, but that is something we have to work on. So what do we do then when it becomes fully effective? As far as inverters, we have plans. If as of 2016, every non-residential inverter must be on a voltage VAR control mode. We're going to push this in the near future to residential as well. So the idea is that all are welcome to connect, but if you cause a problem, you fix it yourself. We spoke and we worked a lot with UMS as well. This is something it was a great vision working with UMS, and that's in the future. You may have heard a lot of the DSO, distribution system operation. We're kind of proposing this ASO, the advanced system operation, because I personally believe, the line between transmission and distribution, that line is gone. Yes, there are rules from perspective of NERC and FERC, but as we speak right now, we got 4 kV, 13 kV, 26 kV interconnections. All are backfeeding to the 230 kV. So when the sun rises, the transmission changes. When the sun sets, the transmission changes. When the cloud comes, transmission changes. So we can't just have this two, separation of church and state. And then I like to say that, basically data is the stairway to reliability and resiliency. And next slide, please. So to get to this point, you really need to have a lot of data. So what are we doing just to move quick? A lot of us are installing their management system. We are in the process of implementing DMS, DERMS, and ADMS, and EMS as well. So we have everything. We don't own generation anymore. There's PSEG, the enterprise, but they may be installing GMS as well. But, we're all installing management systems, but, a common mistake to believe that once you have all the systems, you could basically go to sleep. It's all autopilot. This is only the beginning. These tools allow you to do more simulation, more analysis. It's actually going to show you have a lot more problems. So once all the systems are implemented, yes, the system changes, but we need a lot of changes as well. So we'll see maybe the next time we talk, once it's implemented, how successful is our DERMS. Next slide, please. So we are asked by New Jersey to develop something called the unrestricted system for renewables. They didn't tell us much, just that utilities must develop that. What they're basically trying to say is any interconnection that is being in the queue, you have to accept. And then we're getting more pressure because they're saying that we have to find a way to have a very cheap interconnection, right? They don't want to, I mean, and we don't really do that, but they don't want to hear express feeder, express feeder, express feeder. Find different ways. So how do we really get them? So these are just some of the ideas we were working for. I mean, in my opinion, unrestricted means that every solar circuit has the equivalent of the thermal limit. So if it's 10 MVA circuit, then you have 10 MVA renewables. You know, the advanced control, right? So you could forget about the tap changer. You know, with that magnitude, you know, statcoms, inverters probably will be the main tool. You know, we're going after all the inverters, and then the next step is we want to have full remote control. Now we have some issues because you know the inverters, they're very sophisticated electronics. We don't want to send a signal to cause them to malfunction. So there's a lot of issues for us to get to that point. You know, we're very big on the use of AI and ML, artificial intelligence, machine learning, both to predict the system. So one thing that we're trying to do is, and that would really, before doing any move, before the cap closes or opens, yes, there's a time delay and all the stuff. That's great, but we want to add that weather control. All of us right now, you know, like we make a lot of decisions based on the weather. We cancel vacation, we plan vacation, we cancel trips, we make trips, we cancel meetings based on the weather forecast. And as we get closer to the day, we always enhance. We're all familiar with the rain check and rain or shine and stuff like that. So we'd like the system to be smart enough to look at the weather as well, not just the load before making a move. Again, FERC Order 2222 transactive energy, that is going to challenge everything. So many of us are working together to find the best way really to be prepared for something like that. Energy storage, we expect a ton in New Jersey and I'm sure everywhere else. So we're trying to see what's the best way to smooth the graph that I showed you. And again, we're not in the business of art and craft. We don't want the graph to look nice. We want the voltage profile to be very smooth. So we'll see. And as far as again from operations, we used to have in operations two things: normal operations and emergency. And emergency maybe has one or two categories. Now we're becoming weather experts. We have sunny days, cloudy days, slow cloud, fast cloud, and so forth. And every one of them will impact, and especially in the future when 2222 is fully implemented, if all of a sudden it becomes very cloudy, you just lost a massive amount of solar generation. What do you do? And then, of course, the role of baseload generation. So far, those large power plants have been shutting down in the country. We'll see what's going to happen maybe in the next couple of years. Next slide, please. So, just quickly, again, this is just a quick summary. I like the picture in the bottom right. A lot of these tools, I used to use them when I used to work on Pepco for construction. Now they have solar, they got batteries, so it's kind of the mobility of it, right? So utility remote control is one thing. The reactive, I'm a huge fan of developing a reactive market. Right now, the developers only get paid in megawatt. If they get paid in MVA, then they really care less if they're absorbing active power, supplying active power. They would help the system. And very important, a lot of people miss the point that those reactive power, they're coming from the utility at no pay to die basically at the solar side just to adjust the voltage. But as we shut down a power plant, not only do we lose the megawatt generation and the stability, we also lose the ability to supply and absorb reactive power. So just very quickly, I mean, I think the future will have a lot of statcoms, and then the standards. You're gonna see a lot of standards, and from the perspective of renewables and operations, right? How do you operate when it's sunny, cloudy, humidity? Those of you who look at the solar performance during the peak days, it's very, very poor in the East Coast because of the humidity. It's really miserable, and that would have an impact on substation. I don't know if there's. Can you see? Maybe that's the last slide. Can you check next slide, please? Yeah. So, kind of in closing, this was kind of, I would say, an introduction to a long discussion. Hopefully, we're gonna be together in the next conference to dig deeper. But I personally believe that the substation is the most important piece of land. Period. It allows life to exist the way we know it. Transformer is the most expensive, most important asset at the most important land. So we have to really, really get to the point when we're able to enhance the grid. There's many of us are faced with the challenge that we're not really allowed to invest in the grid. Many of the substations are being denied, transmission work is being denied. There's a fear of stranded assets. But every day, I mean, as we speak today, every single asset that you guys have in your system, including our system, is getting one day older. but they're getting older at the same time when they're really being exercised out. It's almost like, you're growing old and you expect to play a lot more if let's say if you're a soccer player or basketball player. So that's really where we are. So again, I'm gonna stop talking right now to give you guys enough time if you have any questions, comments, concerns. Hopefully that was helpful just to shed some light about what's changing and what we're doing in Jersey. So thank you.
Thank you, Ahmed. So from the chat, I don't think we have any questions, but I'm going to ask if any of the participants can raise their hand so they can ask their question directly. I think there are no questions, Ahmed. Thank you
Sure.
for your participation and your presentation.
I think
Oh, I see one hand. I see one hand. Please go
Yeah,
ahead, Mr.
yeah.
Harpolis.
Hello. It's Pete Harpolis. Just a quick question, and on the LTCs, as far as data goes, I mean, have you seen a really significant impact on requirement or let's say increased maintenance on the LTC?
Yeah, no, that's a great question. So one thing that we do when we and I left planning a couple years ago, but something that we kind of made a requirement is every time you have an interconnection that is a decent size, we always look at our LTC counter on an annual basis to see how often the tap changer changes every year. And then once the site goes online, I mean, again, I'm not saying we honestly do all the stuff, but that's what the checklist we created. We have to visit and we have to see if we see the excessive operations, then we have to really step in. Number one. Number two, I think one of the reasons I think and that we don't see compared to other utilities is our own voltage VAR control settings because the solar interconnection really picked up in 2016, and as of 2016 or even 2015 we made the requirement that every non-residential interconnection must have a voltage VAR control and the voltage cannot exceed 104 per unit at the utility site. So basically that's what I was mentioning earlier, we kind of basically gave the transformer a break because now the inverter is always much quicker. So only that, I mean, the only case we really have a problem is either the inverter is not doing their job properly, or the voltage for us is always high. We have a high voltage. Our system is always running very close to 105 per unit. So by default, the inverters will always be absorbing VARs. But I know, talking to others, they, without mentioning the utility's name, they did see many of them right away when the solar was interconnected. They saw a massive increase in the operations, and also many of them did not really have because they didn't have that much solar before. They had a very short time delay, or even no time delay. So every time the cloud came in, the voltage dropped, the tap changer corrected, and then the cloud is gone. The tap changer has to undo the change. So there are people that had that problem. The one thing we're doing right now, and we are talking to our transformer group, is I asked them a question: is there any issue for our tap changer as a result of all the backfeed? Because it was always designed to basically correct the voltage in a forward feed. That is something.
Correct. Yep.
This is something as we speak we are analyzing. In our 4 kV regulator, when we spoke to Siemens, they mentioned that the current setting for the regulator is basically do nothing. There's a backfeed. That is not going to help us because we have the backfeed every single day. So hopefully I answered your question, but hopefully in the near future when we meet, we want to see. But we right now we didn't see any major issue, and we are honestly backfeeding in every voltage you could think about: 4, 13, 26, all the way to our 230 kV. Yes, every now and then we had a high voltage, but we haven't seen major issue with tap changer. But again, we have this question for Beckwith and for others. As we increase the penetration, like right now, I think the whole state has like maybe 2 or 3 thousand megawatt. The state wants 15,000 megawatts. So that basically is every tap changer backfeeding almost all the time. So more to come on that one.
Okay. Thank you. Yeah. I work in utility in New York here, and I was in the substation area for the last dozen years, and I question things quite a bit with regard to our interconnection process, and where I wound up now. I'm in planning, right? So, thanks for the response, because we have seen significant, increase in operations on the LTC. And, the concern's always been, especially with some of the older type LTCs, right? You're going to get increased possible coking and gassing and so on, which we've seen in a couple of cases. But I was just curious. Thanks.
I agree, and that's why, I mean, my advice to you, and we could chat later if you want. That's what I did from day one. Let the developer. You want to connect, you're welcome, but you're gonna fix every issue. I'm not gonna fix any of your issues so far.
Right.
But the problem is for us is we have very limited staff, so you have to always like babysit the developer because they tell you yes, of course we can do that. Then you find out they're still generating at Unity Power Factor. So, but it's much better because right now, remember, when you go back to your station to do all this work, this is your own O&M budget that you probably have nothing. That's wear and tear. And again, to your point, if the transformer is already 60, 70 years old, and now it's gonna move in a couple of weeks, more than it's moved its whole life, that's a problem. And now, with EVs coming in, that's a whole different ball game because now you're gonna hit the transformer in the morning for solar, at night for EVs. It's not gonna rest. So that's something we need to worry about.
Okay, so that 1.04 per unit voltage is kind of within that interconnection agreement that PSE&G has.
Yeah, initially we had I think it was 104, and some areas we moved it up a little bit just to be fair to the customer because we always generate at high. But honestly, we did not even ask for permission. We just made our own changes. We did two main things or three things. Number one, we required SCADA in a much lower interconnection limit. So we need to see it because otherwise, how do I know if it's even absorbing VARs? I can't tell if I don't have SCADA. Number two is the VV settings. And number three, we installed the latest SCL relay. I could tell you the name. I don't know. It's 7 something that has all of the power quality bells and whistles. Now we don't pull up the power quality data remotely, but it's all stored. So if something happened, we could send our power quality guy, and basically they have ton of data from that solar site. So I would advise you do the same thing. Lower your SCADA, let them control the inverters, and have the latest meter because if something happening, you go there with the Bluetooth, whatever, you download the data, it will tell you a lot.
Right. Okay. Thank you.
Sure.
So Ahmed, I have a question for the group. How many of you are seeing at the peak of the day backflow into the substation, backflow in from the feeder because you've got more solar generation than the feeder is using, or the load on the feeder is using? And how have you dealt with? Have you had any problems with protection settings and so on as a result?
So, Jack, we're seeing, we had an incident, I think it was last year, where we had decent backflow and, up the bank, if you will. And we were doing work in one of the substations, and there was a contractor in there inadvertently operated the switch open. So you put the line in, let's say, a radial configuration, which kind of caused under frequency issues on some of the local circuits that wound up tripping. And a lot of that was due to the back feed, we found out. And, from a technical perspective, not 100% sure what happened because it was actually well over a year ago. And we definitely had some issues, and that was up north. And what was interesting, what Ahmed said as well, is where we're seeing the larger penetration clearly is where land is cheap, right? And your infrastructure is poor. Right. So, in that particular station, we were putting in much larger transformers just to, accommodate the increased interconnections up there. 5-10 megawatt range. So
yeah. Well, thanks, Pete.
And Jack, I would add something that maybe you're not on the same page. I mean, we've been very fortunate that after Superstorm Sandy, that PSE&G replaced all the relays with microprocessor relays. Mm-hmm. Now, unfortunately, others that you may have an issue with the backfeed. So some utilities, again, they have a problem because their system is not designed to accommodate backfeed at all, and the commissioner and developers they don't want to hear it. So that's something maybe that becomes like a great capital work. For those of you guys who have like an issue accommodating backfeed. Either basically the developer pays for it, and then you can have like a it becomes an issue for the system protection group because now you have one feeder with microprocessor relay, the other one is electromechanical. It becomes, this mix and match. But I think for the future, all of us really have to. I mean, you have to accommodate backfeed because you have no choice, and they're not gonna accept no. Some of them have the money; they could do the changes. Others, and we'd be more than willing to share. I think this Monday, the commissioner actually hired Navigant, which is Guidehouse now, to assess all the DR interconnection rules and guidelines in Jersey, and to provide recommendation. I have no idea if this is going to be. I'm sure it's not going to be favorable for utilities. So I'll be more than happy to share. Maybe I'll share with you, Jack. I think it's going to be a live meeting with the BPU next week. And then we'll see. We may end up having very aggressive requirements. And, on the call, we had people like Tesla and others kind of not really happy with all the utility requirements. So,
yeah, if I could just add, and I'm sorry, I just remembered because I was looking through my notes. Generation actually matched load for several cycles, and that was the issue in our scenario where we were in that islanding mode, if you will, and that's when we got into the under frequency issue. So that just made it a little more complicated.
Yeah. So Ahmed, I have one other issue that may stimulate some conversation. You mentioned that you have imposed operating limits on developers, and I'm all in favor of that. But you also said you don't want to invest the capital to fix the problem if they created the problem, and you're pushing the solution back on them. Isn't investing capital in our interest as a regulated utility?
Yeah, no, that's a great point, Jack. So part of the unrestricted system for renewables that we have to develop is exactly that. So once it becomes low or becomes a requirement, we have plans to really go exactly for the commit. For example, like I personally believe in the future, you're going to have the following, a lot of StatComs or some kind of electronics. It has to be fast. So far, StatCom is the only available tool that, plays in the cycle. Plus, you may have some batteries here and there. And this is the advanced system operation. So, so just to correct myself, all the stuff I mentioned, we need them to give us the funding for. What I mentioned by the other point is that when there's an issue, for example, if they stress the tap changer, I'm going to be held, the utility will be held accountable when the tap changer failed because they're not going to do anything. So I let them fix the problem locally by not causing the tap changer to move. But once we get into the point when we can no longer accommodate, we already have circuits that we have more solar than the thermal limit even. So yes, to your point, that's the overall, this is the kind of the strategy that we also worked with you guys, UMS, when we a couple of years ago. So we're just waiting. Hopefully we'll hear from the commissioner very soon about starting this initiative. And that's exactly right. It's going to be, I need the advanced system operation. I need the StatComs near solar sites. I need storage. I also need to have this advanced AI and ML and some weather stations. So yeah, we have a lot of interesting stuff, as you are familiar with, that we want to implement, and they're all going to be capital work. We're just waiting for them to do the first move and giving us the green light to really start this unrestricted system for renewables.
Yeah, it's very interesting. Interesting times, The Chinese proverb, may you live in interesting times. I've been around a long time. I don't think it's ever been more interesting.
Yeah, I mean, you have the EVs, you got the 2222, you got transactive energy, cybersecurity. I mean, I think it's the best, in my opinion, it's the best time.
It's funny you mentioned about the capital spend, Jack, because that's how the utilities make money, right? But when you're under pressure with rates any longer, it kind of becomes a competing interest, where I'd say traditional planning was really based on, let's say, growth, reliability, and infrastructure. Now, where do you fit in this so-called increased hosting capacity? Or, like you said earlier, anyone can connect. And who pays for it, right? I mean, you socialize it. What do you do with it? And that's some of the conversations that are interesting, at least here in New York. And you're actually seeing one of the commissioners was kind of going public, wondering, who's gonna be strapped with the burden, if you will.
Yeah, well, it's a legitimate question.
Sure.
I have. So, do you guys, other than attending webinars like this, where somebody comes out as part of a program, do you guys do any research? I have found that investor calls and the information that companies present to investors on a quarterly basis can be an extremely valuable source of information. I've been wondering for a while about Florida Power and Light. You know, Florida Power and Light has been in the papers recently that Governor DeSantis vetoed legislation that came to his desk that was going to provide great incentives for the solar industry on rooftop solar.
Right.
And everybody said, "Oh, he's a Republican. They're anti-climate change folks, and so on." But when I look at FPL, they're one of the most aggressive utilities in the country in terms of percentage of solar, but it's all utility scale solar.
Right. Yeah, I was just going to say that because I mean, I have a house down there, and you're lucky if you see a rooftop anywhere.
Yeah. And so why do you think that might be? Well, I think the key is
scale, right?
the key is in the earnings report or the investors report that they made. I can attach it if anybody's interested. It's like 200 pages long, but it's full of really interesting stuff. But the key, let me show you a couple of slides out of it, if you're interested in that. So the key here is, can you see my screen?
Not yet.
Yeah.
Can you see it now?
Yeah.
Okay. This is a page that I think tells an awful lot of information. This is their cost. The yellow is the industry O&M cost per kilowatt hour or per megawatt hour, non-fuel O&M cost. And you can see it went for over 30 years, went from 18 or 19 bucks up to 35. So it's about doubled in 30 years. Theirs at the beginning of that period was higher than average. They were 1940 compared to 1869. They have been relentlessly driving cost out of their business to the point where over 30 years, they've taken 50% of their cost out. It went from 19 down to 12, while the industry went from 18 up to 36. So the industry doubled, and they took out more than a third of their cost. What do you think this does? It creates headroom for capital investment, because now I can invest all the capital I want, and the customer is only going to pay 1/30th of it each year if I'm depreciating it over 30 years. And so you might say, well, yeah, but what did that do to their reliability? Well, look at their reliability. This is SAIDI, system minutes lost. And you can see since 2011 to 2021, over the last 10 years, they've gone down in SAIDI. The industry is up at an average of 140, now coming down toward 100, but they are dropping from 80 down to 45 over that same period of time. So they are driving really interesting things through innovation in capital investment. They persuaded their accountants to allow them to capitalize incipient faults and all of the detection. So, most of us get a flicker call from a customer in the call center, and we may send a designer or draftsman or a troubleman out to take a look. All of that is O&M for most of us, but they've got PD detection devices, and they send out a specialist, and the truck roll for the specialist, the PD program, and they find the insulator or the source of what's going to fail, and they write a work order, and the crew goes out the next day and replaces it before it actually faults. That whole process is now capitalized as part of that piece of equipment. Wow. And you can see the results. O&M costs fell, reliability is improving. And here's the chart that shows what's their solar doing over that same period of time. The fall in their carbon emissions on the left, their solar additions on the right. And then here's the really interesting thing. They have managed to persuade the regulator that they should be able to get to the other side of the meter. And so you can see here, FPL will install, own, and operate home charging stations for customers. And that'll give them control over charging, the ability to move their peak to where they want. And they've got similar programs where they will build, own, and operate charging for big commercial fleets in their buildings and so on, bus terminals and so on. So really fascinating stuff. If anybody's interested, I'll attach this to the chat.
Yeah, that'd be great.
Yeah, thanks, Jim. So the one last point I'll mention, right now there's a big push for us to think from a climate change and all the ESG group. So we have a direction to kind of educate almost every group you could think about, to whatever they do, they must ask, am I doing it the right way from a climate change or not? And the substation will play a massive role, because for many, the biggest climate change goal is two things: allow as much renewable as possible and as much EVs as possible. And again, both of them have an impact on the substation. So maybe again in the future we could have another chat about this. But that's really why we believe what we're doing is very important, because we really wanted to be ahead, such that when those interconnection guide comes back, we could explain why we did what we did and what we could do more. So again, be more than happy to discuss, I guess, in the future. But this climate change is the most important thing for us right now at the utility.
I think that's a great idea, Ahmed. Get that on the list and ask everybody what they think about when they're ready to talk about that.
Thank you very much, Jack, for the invite. It was great. Hopefully we'll see you guys in the next conference.
Yeah.
Right. Hey, before you all leave, can somebody coach me on how to attach a PDF to the chat?
You can hit the chat window, or you can send me the file and I will do it directly. Don't worry.
You mean I can do it directly into the chat where it says
Yeah.
type a new message?
Yeah, you can drag and drop basically.
Yeah, but where?
And type a new message there.
Really? Okay, I just tried. Oh, okay. Let me try that.
And in the meantime, as Jack's trying to do that, we will reach out to everybody that participated on the call, and we do appreciate that. If we can't get it attached, we'll send that under a different, we'll just send out an email. And then if anybody has additional questions, they can reach out to me or Ahmed, and we can have further discussions. And then also, I just wanted to mention for those that are on the call, we are having our conference in October. Notifications have started to go out. It's being hosted by Evergy, so we will also, you know, whether you're thinking about it or not, we'll definitely be in communications with everybody that attended today.
Thanks.
No dice, Jack?
No dice, you know, just a total inept, incompetent bozo. I will send it through to
Okay.
Pablo. Pablo can attach it. Thanks, Pablo.
Awesome.
Don't worry.
Thanks,
Happy to
Jack.
help. Thank you, everyone.
Thanks, everyone, for
All right.
attending.
Thanks, everyone.
Bye.
Dedicate your
Thanks,
time.
Ahmed. Thanks, Jack. Bye.
Yep.
Take care.
Thank you. Bye-bye.
Mm-hmm. Mm-hmm.